Okay, so let's actually take a look at what this infrastructure looks like. So let's really look at a remote case. So one of the things we want to talk about is what are those missing steps? So Rob said we want to basically be able to drop ship a box, want to be able to turn it on and deploy a workload. But there's some missing steps in there, and the whole point of this is how do you get the benefit of that without having to build it? So here's the experience we want to build. So imagine you've just dropped off a new server, and we're going to say it's an oil rig off the coast of Nigeria. You pick your favorite location. It arrived. The local equivalent of the Comcast tech plugged it in, and it connected to the net. And the first thing you actually notice is right here, you see a box show up, and it goes green. Now this is incredibly simple looking in the UI, and it's an absolutely horrible demo because it doesn't actually tell you much. But let's actually think about what this really means. So when this shows up, you see a box that goes green. What do you need to know? There's one obvious thing you need to know, which is, well, if we are talking about security, how do we know that we have integrity of the system? So first of all, what you're actually seeing is there's a whole bunch of things that we've done to actually measure the system. And Will went into great detail about what we do with things like remote attestation. But without getting into that, the main key here is that we're measuring every part of the system. When we build the system, the reason we build them is we know what good is. We enroll them. And every time it comes up and continuously through the operation, we measure the hardware. We measure the firmware and the entire software stack. And that includes everything. It's the hypervisor. It's the management systems. It's the software-defined storage. It's all the cool networking stuff that happens underneath. All of that is actually measured, and you know it's good. So the most important thing you know is that it's in a good state. And in fact, we show you the gory details as well. If you actually want to look at the actual PCRs, it's there. And there's actually 2 different pieces of hardware inside, and we're showing you all of that. But the goal here is that you can know by the fact that this is green, that all of that has been done. But there's something less obvious here that is even harder to figure out. When this box comes up on that remote oil rig, how do you know that it's your box and not somebody else's box trying to be you? The other thing that we can do is actually establish unique identity. So when we manufacture the box, we also create the identity. When this thing comes up, you know that it's not only good, but it can only be your system. And that's rooted in the actual TPM hardware of the system. Now, once that's up and running, now let's look at the rest of the experience. This is now the one thing you control in that remote location. So first of all, how do you spend less time actually dealing with managing that entire software stack? All of the security controls, all the virtualization stuff. In fact, we manage the entire thing for you. In fact, the software delivery model looks a whole lot like one of these. Updates happen, they automatically download to the system, and in this case, it tells you we have a new version, and just like with your mobile device, you choose when you take that new build of code, because we put that in the control of the end user. But this way, it's a system that's evergreen, it's always up to date, because you need this thing to work. So now let's look at the other part. What do you need to know about this system? This is a remote system. You need to know that you can immediately deploy an app on the system. But more importantly, you need to know that you can troubleshoot every piece of this system without having any physical access. So how do you know, for instance, if you have a power problem or if you have a temperature or an environmental problem on a system? Usually you have to build out some form of remote management or some IPMI or iDRAC system that you have to build out. This is all stuff that you have to build around your infrastructure. And then there's a question of how do you connect to it, how do you secure it? What we've also built in is a telemetry channel. We know about the health of the system. And the reason is because this is a system you never touch. This is a demo environment for us. We use this with customer demos all the time. This is a box that I've never seen or touched, but I've been using this for the past 2.5 years to do customer demos. I physically don't know where it is, but I know it's always been the same box, and I can diagnose and remotely build any system I need on this platform. It's actually a great example. This is the kind of experience you get. In fact, because we're actually even monitoring the health of the hardware, we can do things like proactive maintenance. We're actually tracking the health of each one of these indicators, and we're actually going even further. There's additional telemetry we gather. In fact, one of our biggest customers, they're using us to rebuild a hybrid cloud edge. They've got a pretty large deployment of our systems. And one of the things we noticed is 1 week we saw the number of ECC errors slowly going up. We automatically monitor that, and we actually saw a trend line going up on our side. We could prove, hey, we've been correcting these ECC errors, but they're going up. We created a proactive RMA, we shipped them a box, and our support guys had a pretty cool thing that they could do. They actually called up the customer and said, there's a box waiting for you at your loading dock. It's there right now. It's to replace this device. We saw some memory errors, and next time you have a downtime, go ahead and swap it. That's the kind of experience we're trying to create. Now, we looked at some of the visibility that we get, but the other thing is, how do you actually get access to these systems, and how do you actually build individual connectivity? So the other thing that we built into the system is a way that you can securely get access to the actual management plane of the system. In fact, what you're looking at is direct access to a secure console. And this is entirely inside the browser. This works in a Chromebook. You don't need to install any software in your laptop. It's entirely inside the browser, but what's different here is that we've not only encrypted this connection, but we've authenticated it with the service. This has solved the problems of authentication. How do you know that it's an authorized user? How do you log the fact that somebody's actually getting access to this console? All of this is done directly through that system. And in fact, one of the things you'll find is it's actually really quick. This is actually a really fast implementation of the console. It feels very much like you're there. And this is really the key in terms of how you get access to this system that you can never touch. And in the end, we can look at some of the advanced traffic analytics, but sometimes there's a problem you need to solve where you just can't figure out what's going on. I've always gotten pulled into things on the networking side. So at some point, there's just a problem you can't solve without actually seeing the packets. And the problem is that probe or whatever way you can get access to that traffic is just never where you need it. So the other thing we've built in is remember that we're also delivering a software-defined network engine underneath. The other thing we can do is remotely enable you to actually mirror traffic out in real time. So you can actually see all the packets going back and forth for each individual VM, even remotely. And remember that for a secure branch, having this tool is cool, but the bigger thing we're trying to do is, in one of these remote compute facilities, the hardest problem organizationally is what happens when you have different people owning different applications. Maybe your AD owner needs to get a packet trace to figure out why they can't RDP in, or maybe another application owner needs to be able to get a look under the covers to figure out what's going wrong with their app. Because this is built into the same system that's multi-tenant, now the person that owns the app can actually go get access to these troubleshooting tools without opening trouble tickets and without sitting on conference call.
Okay, so this is kind of a virtual span port?
Yeah, it's conceptually very similar to RSpan. So it applies to all traffic going to and from the VM NIC, and you can tell it to actually encapsulate in VXLAN or GRE, and you can send it to any location. In fact, here we're actually sending this to...
But that means I need as much bandwidth between here and Singapore as the traffic I'm trying to look at from somebody local in Singapore to your box in Singapore.
Well, that would be unpleasant, especially in that part of Asia. Bandwidth is a little expensive.
Yes.
In fact, what we're doing here is I'm actually sending this traffic stream to another VM in another compartment in the same system. I'm actually using this to play with a NetFlow probe inside, just because I wanted to compare and contrast what NetFlow can do.
Okay.
So here, I actually just directed that to another VM, and we just literally U-turn the traffic locally. So what we normally see...
And then I run Wireshark in that.
Absolutely. So this is the point of why we want to have the tools here, because now you can have... Think of this. Now, on top of everything that we have here for telemetry, now you can have a shared tools platform sitting in a remote site, where you can even do things like packet analysis, you can do things like local troubleshooting, and all of that is just something else that you can deploy inside the same platform.
Okay.
So this is really what we think matters in terms of how we deploy that type of remote compute, how we enable that experience of first you can drop ship something, and then once it's there, you have full control, and you can actually enable individual users to get access to that. With that, I'm going to actually get to my...
So now I have to talk about the storage part, because what I do. So there's SSDs in the box, and all of these VMs are running on those SSDs in the box, and those SSDs are mirrored.
They're rated, yeah.
Okay. And you're working on a clustered file system so
Correct.
that. And how much usable storage can I get in one box?
So right now it's 2.4 terabytes of storage. That's after the redundancy inside the box. And obviously with things like clustered storage, that allows us to have different mirroring schemes and different usable capacities and cluster those devices. The other thing that's also less obvious, though, is that the other thing that's happening as part of that software-defined storage layer is we're also doing encryption of the volumes. And we're doing that at a software layer on top of the actual block device. So what it allows us to do is now each individual VM is sitting in a separate software encrypted volume where we manage the key, but we're not actually trusting the underlying disks to protect it.
Right. And each VM has a unique key.
Correct. And that key is actually rooted in 3 places. It's rooted in the TPM, and it's also rooted in PCR measurements. If you try to modify the hardware, you'd invalidate it. And part of it is actually in the cloud service. So if you're running something...
Well, it would have to be, because if somebody steals an appliance, I got to be able to restore that VM.
Exactly that.
Precisely. And it also it allows you to solve the one problem that you have with things like BitLock or traditional disk encryption. Imagine you're running something like a domain control in a remote site. You don't want to have all the key parts sitting inside the piece of hardware because you just forklift the server and then you've got all the key parts. But then if you do that, how do you get it to auto boot if you want to remove part of that key? Usually you have a system where somebody actually literally has to type in a boot string to actually be able to unlock that. Here we can provide that from the actual cloud service. And also, if you control this, you can actually withhold that part of the key component. So you could actually remotely disable that encryption and actually withhold that key. So it's a level of assurance that you get for actually protecting things in the remote site as well.
So hopefully you get to this at some point. You don't have to address it if it's on the agenda, but the big thing is data protection. I know you guys talked about it, backup specifically, backup and archiving. Mm-hmm. How do I get secure backups out of this and back onto a system?
Okay, so that's actually a great question. So we have this actually inside the system, and I'll give you a quick look at what we're doing here.
And while Dan's bringing that up, we have some time right after the live stream ends to kind of go through more questions. So we'd love to pick up on these questions. There's one more section that we'd like to squeeze in if at all possible.
I think you'll like the next section. So that one is I think actually one of the most interesting things. But just so you can see it, what we have is we've built in a backup facility, and this is really designed around 2 things. So first, we can do backups to external systems, and what Will mentioned is one of the things we've also built in is these external data stores can also be things like S3. So this way you can actually get remote access over an encrypted transport to a cloud-based facility, especially for remote branch. The other thing that we can do is for redundancy, we can actually do disk replication between physical devices as well. So for data protection, what that gives you is continuous disk snapshot and replication, and we preserve the encryption envelope. So it's data at rest on one device through data in motion through a secure connection to data at rest on the other device. And that's something that you can configure very simply and easily to automatically apply between 2 different systems.
That's low RPO, RTO with basically, as soon as you observe the problem, you can migrate the workload over, and it'll resume a couple of seconds behind.
Okay.
And one of the things we're trying to solve here is like...
And I can set what would effectively be a snapshot schedule to create...
That's correct.
Revert.
Yeah, exactly. Yeah.
It's funny, if we talk about things like redundancy and data replication, the number one thing we see is it's something that everybody depends on, but this is really where most of the complexity comes in. If you look at literally high availability guides from traditional hypervisors, it's extremely complicated. And understanding the difference of things like live migration for proactive maintenance versus actual disk replication for data protection, this is where we see a lot of people make a lot of mistakes. And those mistakes, just like we found earlier, generally you don't find them until you run into a disaster. The other thing we're trying to do is make this something where it's a couple clicks and it's done right every single time. It's designed to be very simple, very consistent, and self-validating and verifying too.
Sure. Actually, I think that's all we have to say about branch. I mean, so yeah. Are there any questions? Do you guys have questions about it? I don't have much to add. Sorry. Great.
Cool.
That's back to Dan.
All right, you're going to hear me get a little animated about this because I think this is pretty interesting. One of the areas that we see a lot of attention to now is not just things like critical infrastructure of branch, but there's a whole other area of the data center that has really changed because of cloud. So one of the places actually where we've got some of our largest deployments is actually solving the problem of how do you create a secure bridge between a data center and hybrid cloud environments. And we're not talking about how do you solve the problem of continuous management and orchestration integration. This is literally how do you secure the communication between apps running in your data center and actually communicating out to be either SaaS services, PaaS services, or IaaS services. And if you look at one of the challenges, look at some of the security gear that you have on the edge of the data center. Cloud really changed a lot of things. And one of the things that we actually talk about here is that effectively cloud has kind of broken what firewalls can do to actually protect you from the traffic moving to cloud. So what happened? My background is networking. I've spent tons of time working in firewall policy, and it's usually not the most fun thing. And one of the challenges is if you start looking at how you actually build policy for cloud, in most firewalls, it all comes down to an IP address or a range of IP addresses. I can't tell you the number of times that I've spent building address books and lots of lists that you can start to refer to in policies. And the firewall vendors are doing a lot of work to try to make that simpler, but in the end, you're managing lots and lots of lists of addresses, and it all comes down to IPs. But cloud has really changed the concept of what an IP address means. In this case, if you actually plug something into cloud, you have an interesting problem. Let's say you have a gateway that's talking to a SaaS service. Let's say you're talking to maybe Slack. You have a little gateway that's plugging something internal into Slack. That's got to talk out to the internet. And sure, if you own the application, you're going to deploy that. At some point, you need to talk to the firewall team and say, I need you to open a rule that allows this thing to communicate out to cloud. And they're going to come back and say, what address is it? And that's when the fun starts. You just have a URL. You can't usually tell them the IP addresses. Okay, so what has the industry been doing? So if you start looking at the network security vendors, what you're going to find is people who are doing anti-malware, next-gen firewall say, all right, well, maybe you can't rely on what an IP address means anymore. If you're doing policy, the only thing you can do is actually start looking at what's in the traffic itself. You start to find lots of things that are tearing apart traffic, doing really smart things, looking for objects. It could be malware or viruses, or they're trying to do things like application identification, sniff out whether that web connection is really just BitTorrent or something else. So there's been some amazing work around this. And this is generally where we found a lot of the best features are looking deeper and deeper and deeper into the protocols. There's one other thing that's changed about cloud. Now it's all shifting towards encryption. So if you're trying to solve this problem by being smarter and digging deeper into the traffic, the problem is once it's encrypted, you can't do anything until you actually decrypt it. And you can deal with it. There's ways to do things like man-in-the-middle attacks. You probably have man-in-the-middle proxies. You can try to install certificates in different places. But this is getting painful. So what do? Like, this is actually kind of a big problem, and it's kind of shocking nobody is talking about this. This is something that is happening in everybody's network right now, and it's amazing. As we talk to enterprises, people kind of tacitly know about this, but nobody's actually saying, how do we fix this problem? Let's actually dive into this. And it's interesting because if you talk to the people who are deploying the apps, they never really see what has to happen on the security side to make this work, and it's kind of fascinating to walk through it. So let's say you're somebody that needs to deploy an app, and you got to get this thing deployed next week. You got to hit your deadline. It's this simple thing. All it's going to do is talk to cloud. Maybe it's going to send logs to Splunk. Maybe you're going to do APM data up to something like New Relic that's going to do some cool analytics. And it's awesome because it's in the cloud. And the best part is you plug it in, and it just calls out to cloud, and you're done, right? Okay. So how do you connect it to cloud? Well, if it came from somebody like Google or Microsoft or Facebook, somebody really big, you might have a prayer of doing some policy based on actual IP addresses. You can read the BGP tables, figure out where they are, but in most cases, you're not going to get that lucky. Most of these are actually running in a shared address space like Amazon. So it could be something like the usual offenders, or it could be something like Slack or any one of the other services that are all running in Amazon. So now that's one huge pool of addresses. We have another slide that we can go into that looks at like how much address space. Amazon is over 1% of the entire internet IPv4 space. It changes every day. It's like, last time I checked, it was 980 IP prefixes. Like, you literally cannot build a firewall policy that says go to AWS. Everybody at some point tries and gives up. And the rule you actually build is allow from this one IP address, web anywhere. You've got no choice. You cannot classify all of Amazon at this point. It's too big. But it's actually worse than that, because you can make arguments that Amazon, sure, I can get a static address, I can force them to do certain things. If I'm doing IaaS, I can kind of map it to a hard address. But it actually gets worse. Once you're in SaaS land, every single one of the SaaS providers is actually sitting behind a web front end. They're sitting behind Cloudflare or Fastly or a CDN like Akamai. And now you're having even more fun, because guess what? There is no such thing as a static IP. Literally every website behind Cloudflare is behind the same IP addresses.
Yeah, and
literally every
you
website.
can't build a VPC in clouds. I mean, because the solution in AWS is to build a VPC. And
Absolutely. In a VPC, you can have a static address. And sure, you can solve the problem that way, but it actually gets worse, because part of this is organizational too, right? So let's say you get a static address from Amazon. Okay, so you're doing an IaaS, you get a VPC, you get a static address. Now's where the real fun starts. Let's say you're now going to transport over the internet and you get a static IP. Well, Amazon's rules actually say that if you ever lose it for any reason, they actually guarantee you will never get it back again. So now that rule that you put to that static IP in your edge firewall, if something happened, now somebody else owns that address until you go back and garbage collect those rules. And that happens right anytime now. And that's part of the problem. And here it's impossible.
yeah,
Any SaaS service, forget it. You literally can write no rule that will actually classify it. So this is even worse, because that's usually going to Amazon too. And the real reason you care is at this point, think about this from the point of view of an attacker. What do they know about every enterprise and their firewall rules? There's a whole bunch of stuff inside the data center that has to talk to cloud. And at some point, the security guys gave up and said, allow any out, or allow out to Amazon. And that's where they sit. If you're going to build a C2 controller, if you're going to build an exfil site, you put it right there in Amazon. You use a stolen credit card and you do exactly what the Mirai botnet server did, because that is whitelisted in every firewall of every enterprise. That's kind of scary. So this is the really scary part. So, okay, great. So let's solve the problem the way network security vendors want to solve it. So we're going to dig into the traffic. We're going to do amazing stuff. We're going to start doing application identification, lots of really, really smart stuff. We're going to start reassembling TCP streams. I spent too many years dealing with this stuff, so I get excited about this stuff. But the problem is, something's changing. Now, first of all, we've already passed the Rubicon. Outside the fire, we've already passed the 50% is encrypted Rubicon. Everything is going encrypted now. What's changing is the protocols are changing. So first, HTTP 2 basically says encrypt by default. That's going to raise the bar up for everything that's encrypting. So if you're relying on seeing the traffic go out, any HTTP 2.0 enabled site, boom, encrypted. Okay, so now let's say you're trying to do something smart. So maybe you're going to try to start looking at the certificate that comes back and do policy on that. All right, great. Well, the problem is TLS 1.3, the new version of the successor to SSL, has now sped up the encryption algorithm. And now, as soon as you establish a connection out, everything coming back from the service is encrypted, including the certificate, which means you see nothing that comes back from the service. That's ungood. But there's one more thing that's even worse. Think about these SaaS services that you're connecting to. They usually have a little VM appliance that they give you, and it's great because you just plug it in and it connects out to the SaaS service. It just works. But what they're doing now is they're actually trying to make sure that nobody is going to try to man in the middle them. So what they're doing is doing certificate pinning. They're encoding the only certificate that they will allow to communicate directly in the app. And once they do that, you're done. You are no longer able to decrypt that traffic. You are not allowed.
So you got to find it in the DNS before it goes out.
That's one of the things you can try to do. And let's actually talk about what you really do. But the bigger problem is, no matter how smart you are, it doesn't matter how many millions of dollars you throw at network gear to try to be smart and do stuff, you're done.
I can't spoof the PIN certificate.
If you had the key.
Or it's built into the application.
Oh, no, right. I need the private key.
Yeah.
Right. So, okay, so this is bad. But it's getting worse. Because the other thing that's happening is people are starting to get smart about the applications inside the data center. So Rob actually mentioned that about 70% of the revenue of some of the network security folks are looking at how do I do better segmentation and better security inside the data center. Well, what else is happening? It's not just the stuff on the outside. First of all the internal applications are starting to move to web protocols. And then, by the way, the libraries that these things use to communicate are now being updated to encrypt by default. One of our biggest customers is a massive blue chip company. They are the people that you would expect to be slow moving. They are pushing us to support NFS 4.1, which does Kerberized encryption for file transport. You take things like that. You take things like SQL connectivity, where the libraries they use are being updated to mandate encryption. And you lost visibility on the inside, too. This is an interesting trend that we're not hearing a lot about from the network security side, because this is a little scary. What are we going to do?
Yeah, there. So I move the blue app and the green app to microsegmented DMZs.
Mm-hmm.
My Oracle server is accepting unencrypted traffic. So I see it at that point.
As long as it's still accepting unencrypted traffic. It may not be the Oracle server, but as you start going to some of the newer database technologies, things like the NoSQL stuff, a lot of those libraries are actually moving to encrypted transports as well.
Yeah, but they have to let me do a man in the middle because I own both sides.
At some point, yes, but it's starting to encrypt by default. So the main point is you will have more control here. Here they can kill you with cert pinning. Here, now you have a bigger problem. The people who own those apps are not necessarily the ones who would own the man-in-the-middle capability.
Well, oh no, and you start talking about the scale of having the middle that you have to build to decrypt all that stuff and re-encrypt it. It's
Oh, well, and then there's another valid point. So Google and Cloudflare published a paper earlier this year, and it's basically a warning shot. What they're basically saying is, look, if you're doing man-in-the-middle somewhere in the middle of the network, that is actually a security vulnerability. Like, think about it. Once you do that, you have one place where you can laterally move between every application and violate the crypto envelope. It's a built-in escalation point. And what you're starting to see is the people who actually control both the browsers and the service are basically starting to say, man-in-the-middle is bad, you shouldn't do it anymore. And they control a lot of the libraries that these things are built on. So if you're relying on being a man-in-the-middle, it's going to get tough. Not impossible inside, but it's going to get tough. So there's an uncomfortable question. For all the security stuff that is sitting on the outside of your data center, what is it actually doing? Once it's all encrypted and you can't man-in-the-middle it, it's basically acting as a one-way valve. It's enforcing directionality. That's about it. And the problem is, you have new things to think about. So that perimeter, it's not just about whether that perimeter is getting harder to fix, but now the problem is your apps don't actually live inside anymore. So now you've got applications that live maybe in an IaaS. Let's actually come up with a simple case. You've got an app that's sitting in AWS, and then it's talking to something inside your data center. Let's put this on the table. AWS is probably more secure than your data center. This is not a knock on AWS. That is highly secure. But their security is not designed to protect your app. Their security is designed to give you a secure place to put your app, and their security is designed to protect them from you and your neighbors from you. They will not secure your app. In fact, your Amazon instance is only as secure as the code you put inside. So what happens? Okay, well, most of the time, you have somebody who owns this application who needs to connect internal services to AWS, and how do they do that? 9 times out of 10, it's probably an IPsec tunnel. Is that IPsec tunnel terminating in the edge firewall where maybe it should? Probably not.
Well, it should be terminating in the edge firewall in my VPC, but it's probably not doing that either.
Probably not. So, and the biggest problem is you actually have an organizational problem. Why isn't it at best in your data center? It should be in the edge firewall because then you can apply policy.
Because that's the marketing guys and their credit card, and they never talk to me.
Yeah, and if they did, the security team would say, no problem, we can get that configured for you in, I don't know, a month. So this is the risk, is now you have an encrypted connection to the heart of your data center where something out here can easily get in, and if it got through, you would have no visibility and no policy control. And this is a reality in every data center that I've been in recently. And the number here isn't just 1 or 2 IPsec tunnels, it's usually dozens or hundreds going to different VPCs. So what do you do? This is your point earlier, is what can you actually start to do? The answer here is security isn't in the network anymore. What's changed about cloud is the way you connect between hybrid cloud is an application. It's not a network connection anymore. Once you do that, you can start to do policy to actually control where these things are allowed to go. Simple example. You've got a connector that's talking to Salesforce and it's connecting to your ERP system internally. Keys of the kingdom, line of business application inside. That's the only thing authorized to talk to it. You can start to build policy around that. That's where microsegmentation starts to matter. But context matters too. You need to know that that is the only thing that's allowed to talk to your ERP system, and nothing else is allowed to spoof that communication. You need to know that it's actually also going to the real SAP system, by the way. The reason you care about that is what if that's an authentication gateway? How do you know it's talking to your real domain controller and not a fake domain controller that somebody put up and spoofed SRV records for? Also, these cloud gateways have one thing that is more critical than anything else in your data center. Think about what you actually own in cloud. If you have a Salesforce instance, do you own anything in there? You're renting it. And in fact, the only thing that you have that you actually own that controls your Salesforce instance or your entire VPC is credentials. It's access keys. And guess what? They're sitting right inside that system. You want to own somebody's Salesforce? You own the connector that actually has those access tokens built in. This is why this stuff matters. This is the other problem, is it's not just about security, it's how long it takes to make security policy changes there. This is, we jokingly talk about this is how you explain this to the CIO when it's not a security discussion. The real problem is if it takes you 6 weeks to get a firewall policy in, and that's not unusual, that's a problem. Here's how we propose solving it. We talked about a hybrid cloud edge. It means a couple things. Security moves to a VM or an application. Security has to be separate for each one of these VMs. We want to build a microsegmented swim lane for each one of these apps. And this effectively becomes the new DMZ. This is how you solve security for hybrid cloud and build a secure bridge. And in the end, this is what your experience looks like. If this is going to work, it works because it's self-service. You're the app owner. You deploy the VM yourself. You don't open a trouble ticket with the virtualization team. You get to put it there. You get to manage policies, and because they only apply to your app, that's all you got. You can't break somebody else's app. You can update the policies yourself. And with the visibility we talked to, you can also troubleshoot these policies. And I'm going to wrap up early here, and we're going to skip a little bit of the demo because we're running a little bit over. But we think this is the key for how you solve this edge security problem. You have to solve the organization problem of how do you allow people to do self-service deployment. You have to be able to give them policy that is actually cloud aware, where you can build policy based on the actual service names. And you need to give them a place to put it where it's easier for them to put this in the right place than it is to deploy this inside the data center on their own. And this is how you keep control. So I'll pause there before we sort of wrap up on this. And I know we covered this quickly, but I think this is what we think is a pretty exciting use for this technology because it actually changes both the organizational impact and how you do security for cloud. So this is the other thing that we're also announcing here is it's not just about hosting these apps, it's also about being able to now actually allow the IPsec termination directly into our system in this hybrid cloud edge and manage the microsegmented connectivity to the VMs inside. So imagine now you can make self-service not just for these gateway apps, but now you can allow people to actually deploy and terminate the IPsec connection and then stitch it to only those systems internally that are authorized to actually communicate out and visualize this. Again, you have to make this work for people that aren't network people. And this is what we really think matters in terms of how you solve this hybrid cloud security problem correctly.